So welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is building blocks of autonomous ship. And this is also part of the main playlist of maritime technology. And I have done another video on the topic of key pillars in autonomous shipping that can provide an introduction to this video. So therefore I would recommend you to go through with that video also. And the link to that video will be placed in the description of this video. So let's move on to the main content of this presentation. So let's talk about the respective building blocks of autonomous ships. So here the first building block we are going to discuss in this slide would be automation system. Generally, automation systems consist of a propeller or thrust control system coupled with a rudder control system. So I am considering a conventional vessel in this situation. Of course, the automation system can vary from vessel to vessel, but this is a general representation. So then propeller and thruster control system often associated with engines or batteries and electrical motors to power the system itself. And then rudder control system is associated with this rudder steering system. And the parameters we are going to control under rudder's control system would be rudder angle and rudder rate. And under the propeller and thruster control system, we would control this propeller and thruster pitch and speed. So if we expanded that further, so the propeller and thruster control system often control the speed of the vessel, and then rudder control system with support to control the heading and the course of this vessel. So if you are combining both speed control and heading and course control systems, you end up with the behavior of this vessel. So this is where the vessel seakeeping and maneuvering conditions can be coupled with. So eventually this vessel behavior and then information from automation system along with the vessel navigation should be displayed. That can be done under integrated bridge system. So this is where this information visualization could play an important role. In this figure, I have divided this integrated bridge system into several sectors. So the first sector is the onboard IoTs, Internet of Things. So that consists of several systems and sensors. So I am displaying the first system as GNSS, that means Global Navigation Satellite System. So this is where the vessel position information can be obtained. And then the second system is INS, which is the Inertial Navigation System. Since these vessels having 6 degrees of freedom, pretty much the translational and rotational motion information can be obtained through these INS systems. And then additionally, these vessels can have a LiDAR unit, digital cameras, and then weather transmitters where the information on the surrounding weather conditions can be obtained. And generally, the main component of the integrated bridge system would be the navigation system that consists of radar and ARPA radar. So that means automated radar plotting aid. That's what ARPA stand for. And then ACDIS system, that means electronic chart display system. This is where the vessel position can be displayed in a geographical map. And then the conning system, this is where pretty much the vessel information such as this course, heading and speed and so on information can be displayed. In addition to that, this automation information, for example, the operational conditions of the propeller thruster and the rudder control system, including some engine information, can also be displayed in the integrated bridge system. So when you talk about integrated bridge system, it is somewhat more complex combination of various information sources which can help humans as well as the digital navigators in ship navigation. So eventually the environmental conditions in the surrounding of the vessel navigation could influence the vessel behavior. So these external environmental conditions can be categorized as this ocean wind conditions, wave conditions, ocean and tidal current conditions, and then possibly ice conditions also. And then the water depth and the land mass conditions around the surrounding area of this vessel navigation can also influence on this vessel behavior. And then, so this is what we can say as the process of human navigator is controlling these vessels. So here the human navigator make navigation decisions and then turn those decisions into navigation actions. And those actions would be implemented on the vessel automation systems. And then these navigation decisions are based on the information from the integrated bridge system. And here we are proposing two important technologies that can support human navigators as well as the digital navigators when these digital navigators are controlling the autonomous ships. So the first technology would be this advanced ship predictor. So the advanced ship predictor can be used to predict actual ship routes and vessel motions within a selected time period. This time period can be a small scale or a large scale depending on the local and global conditions you are looking into. I would have a separate video on this development of a advanced ship predictor. So the second proposed technology would be digital ship routes. So the digital ship routes can be seen as vessel traffic lanes that can guide future vessels to navigate safely. So this digital ship route could display the required ship routes and the motions. So since we have these required ship routes and motions from the digital ship routes, and then you have this actual ship route and the motion from the advanced ship predictor. So the ship navigator can compare this required and actual ship routes and motions and make their navigation decisions based on those information comparison. And these navigators could be human navigators as well as the digital navigators in future vessels. And then on top of this ship navigation process with the human navigators, we would develop this digital navigator utilizing deep neural networks. I think I have discussed this process of developing this digital navigator in a more detail in the previous video, so I would recommend you to go through that video also. So here we are utilizing deep learning type of framework to clone the human navigator behavior. So let's see how we can do that. So let's talk about the training process of digital navigator. So initially these vessels will be, these conventional vessels will be navigated by human navigators. So during that process, we would collect human navigator behavior from one end, and then the other end we would collect the navigation information of the vessel. And this navigation information would come from the integrated systems. So when you have this navigation information and the human navigator behavior, those type of real world ship navigation data sets will be utilized to train deep neural networks. So that process is called a training process. So here what we are trying to do is we try to capture the human navigator behavior through the deep neural networks. So eventually when you have a more mature deep neural networks which has quite a lot of information on the human navigator behavior, then we can categorize that as the digital navigator, and which we can utilize towards future autonomous vessels. So when you have a more mature digital navigator, eventually we will utilize these digital navigators to operate fully autonomous vessels. So in fully autonomous vessels, this human navigator can be replaced by this digital navigator to make the navigation decisions, and then eventually these navigation decisions would be converted into navigation actions on the automation system. And that process can be categorized as this execution process, where these navigation decisions being converted into navigation actions by the digital navigator. And then we would believe that digital navigator itself or the cloned human behavior itself would not be enough to navigate these future vessels, because there can be more complex situations where you may have to make more complex decisions. So because of that reason, there's a requirement of decision support systems to be on board for these digital navigators. I think even the human navigators been supported by various decision support systems. I think that requirement should be there also for the future vessels. And here I am representing some selected decision support systems that should be there to support this type of a digital navigator. So these systems can be voyage planning and route segmentation, pilotage, simultaneous localization and mapping, weather routing and safe ship handling, ship stability calculations, then situation awareness and collision avoidance. That can be one of the most important decision support systems, and then vessel and ship system condition monitoring, especially the health condition of the systems in these future vessels would play an important role. So obviously these decision support systems should be facilitated with various information resources. Here I am presenting some selected information resources. So the first one would be energy efficiency and emission control rules and regulation. So if these vessels are navigating in a ocean area where there are tighter emission control rules and regulations are implemented, then these digital navigators can select what type of a fuel or engine configuration should be utilized to navigate these vessels. So voyage planning and route segmentation can be utilized by this type of energy efficiency and emission control rules and regulations. And then digital maps and navigation rules and regulations. This can be a part of this pilotage type of decision support system. So if you have a global and local weather information, that can be utilized under weather routing and safe ship handling type of decision support system. And then vessel traffic information and vessel traffic separation schemes can be utilized under the situation awareness and collision avoidance type of decision support system. And then AIS and LRIT, that is long range tracking identification and tracking system. So that type of information can be also utilized under the situation awareness and collision avoidance type of decision support system. So the main point would be this decision support system eventually help the digital navigators to make more complex decisions under various ship navigation situations. So these information resources should be supported or provided by supporting services and authorities. So here I have some selected supporting services and authorities are displayed in this slide. So this can be various maritime authorities, port authorities, and weather centers, and then vessel traffic and traffic management and information systems, probably managed by various maritime authorities, could provide this type of information resources to be utilized under these decision support systems, which can support the digital navigators in future vessels. So this is the overall framework that we have discussed in this video. So the bottom layer would be this external environmental conditions. So then vessel and the ship system would be in the next layer of this framework. And the following layer consists of the human navigator. And then two important technologies that we have proposed to support the human navigator as well as the digital navigator in future vessels, which consist of this advanced ship predictor and then digital ship routes. And then the next layer would be the digital navigator. And the following layer consists of various decision support systems. So the top two layers in this framework consist of the information resources and then supporting services and authorities. So that's the end of my presentation. So hopefully you have enjoyed this also. So if you are still interested, please stick around. Thank you.